Hi, this is Namla Rednam. In this video, we are going to discuss the solved examples, try these and think, discuss, write section of regarding exercise 9.2 from 9th chapter mensuration from NCERT textbook class 8. Okay. Now, in the previous video, we discussed the formulae for the total surface area as well as lateral surface area of cuboid, cube and cylinder, right? So, let's quickly look at the questions that we have. Now, look at this figure. Why is it incorrect to call the solid shown here a cylinder? The reason being, we have seen that in a cylinder, you need the base and the top to be congruent, right? Here they are not congruent, and that is the reason why it's not a cylinder. If you actually look at this, we have already discussed it. This, if it is 90, then it's called right circular cylinder. Right because it's 90, circular because base and top are circles. And here it's not a 90 degrees, it's it's a different angle, therefore it is not a right cylinder, right? So that is about the first question. Next I have, you have to find the total surface area of these two. We have looked at the formula. It's 2 times of LB plus BH plus LH. If you apply that formula, you will get the answer here. If I take L as this is my L, this is B, this is H, then LB is 24 and BH is 8 and LH is 12, and I have to take twice of that. That will give me the total surface area, right? And so the answer is, this is 20 and 20 plus 24 is 44. So I have 88 square centimeters. So that is the answer. In the second cuboid that they have given, again if I take this as L, this as B and this as H, LB is 16, BH is 40 and LH is again 40, right? And I have twice of that. This is 96, right? And twice of 96 is 192, right? So that is the answer for square centimeter. That is the answer for this. Try this question. Next we have, cover the lateral surface area of a duster using the strip of brown sheet and remove the paper and measure. Will it give you the lateral surface area? It will. That is how we found out the formula. And it is lateral because you are covering only the lateral surface. So yes, it will, right? So the answer is yes. Measure length, width and height of your classroom and find the total surface area. You already know the formula for total surface area, lateral surface area. And lateral surface area means you're going to exclude the floor and the roof. So if you're taking the floor dimensions as L by B, then you will be excluding L into B. Total area of the room which is to be whitewashed, again this is nothing but the lateral surface area, because you will whitewash only the walls. You're not going to whitewash the roof and the floor, right? So that is the answer for that question. Can we say that the total surface area of a cuboid is lateral surface area plus twice of area of the base? Yes, because in a cuboid, base and top are congruent, right? And lateral surface area excludes area of base and top. So if you add those two, then you get the total surface area. So yes, you can do that. If we interchange the lengths of the base and the height of a cuboid to get another cuboid, will its lateral surface area change? Now here what they have done, if you notice, they're using the same cuboid, they've only changed the orientation. That is, in the first figure here, my base here is LB. And in the second figure, the base is BH, right? Now, will the lateral surface area change? It will change. It is going to change because lateral surface area is the surface area that excludes the base and the top. So, it depends on which face of these 6 faces you're going to take as a base, right? Depending on that, your lateral surface area is going to change. In fact, that is how we wrote the formula in the previous video. Depending on what is your base, your lateral surface area is going to differ, right? And then draw the pattern and you'll get the net. This we have already discussed in the previous video. You get the net of a cube, and then from that you can by making the foldings in the creases in all the lines, respective lines, you can get the cube. What is the length, width and height of a cube that you have obtained? And observe that in this case it is L. All faces are squares. Okay, write the area of each of the, we've done this. Okay, it's not A here, in this case it is L. So area is L square. Are they equal? Yes, they are equal. Total surface is 6L square, right? Each face, if each side is given as L, then it is that's what you have written. Area of each face is L square. Can we say the total is 6L square? True. Yes, we can say that the total is 6L square. Next question. Find the surface area of the cube on lateral surface area of the cube B. Now here, if L is 10, okay, 6L square is nothing but 6 into 10 into 10, which is nothing but 600. And lateral surface area is 4L square. So I have 4 into 8 into 8, right? So that will give me, so here it is 4L square, which is 4 into 8 into 8, which is nothing but 64 into 4, 256 square centimeters. So that is how you can find the surface areas. Now here, two cubes each of side B are joined to form a cuboid. So if you join two cubes, you are going to get a cuboid. What is the surface area of this cuboid? Now, you know that surface area of each of these cubes is 6B square, correct? I have 6B square here. Now here, if you look at the surface area of this cuboid, now what is the length of this cuboid? It's 2B, breadth is 2B and height is 2B. These are the dimensions, right? So if you look at the total surface area, if you use the formula, you have 2B square here, LB, BH is B square and LH is again 2B square. If you simplify this, I have 2 plus 2, 4 plus 1, 5 into 2, 10, 10B square. So you can see that it's not actually 12B square. It's not simply the sum of the surface area of the two cubes which were used to form the cuboid. If you join 3 such cubes, is it going to be 18? From the previous answer, clearly you can see that no, it's not going to be 18. Okay. So here also you can actually find out and check. 3B, B and B are the dimensions, right? So I have, so here I have 2 times of LB plus BH plus LH, right? So if you add this, 7 to 14. Okay, it's not 18B square, it's 14B square. Now he's asking why. Now this is important. Can you think of the reason that if you simply add the surface areas of the individual parts, you're not going to get the total? The reason is because you can see that here, this particular face is getting, it's going inside the cuboid and so it does not belong to the surface anymore. So if I can show you the cuboid, cubes from the cubes, let me show you. Here I've got two cubes, right? So when I'm joining these two cubes, right? If I join these two cubes, you can see that these two faces, this face of this cube and this face of the first cube, they are going to become a part of the interior. They are no more on the surface of the cuboid, of this cuboid that we get, right? Therefore, of the 12B square that we initially expected, 2B squares are going to be, get subtracted, and that is how you're going to get 10B square. We've got 10B square, right? Now, similarly, even for 3 cubes, same thing is going to happen. What's going to happen is, I have another cube coming here, right? Again, this face and this face. So, 2 more B squares are going to go inside, and therefore, from the total of 18B square, okay, I'm going to have 4 b squares cancelled. That's why I've got 14 b square for 3 cubes, right? So that is one way of trying to understand why it is not simply sum of the individual surface areas. Now coming to the next question, how will you arrange 12 cubes of equal length to form a cuboid of smallest surface area? Now this is a very interesting question. Let me first show you the, I have actually made 12 cubes. I'm going to show you. So what they are talking about, what are the possibilities? So if you can see here, I have got 12 cubes, right? So you've seen that with the 2 cubes, they have made a cuboid, right? And that's the only possibility. With 3 cubes also, you can make a cuboid, right? Suppose you have 12 such cubes, right? There are certain number of cuboids that you will be able to make out of these 12 cubes. First, the question is, how many cuboids can we make? Because randomly I can't place it, as I wish. For example, if I place them like this. Now, this is not a cuboid, right? This is not a cuboid. So, how many cuboids can I make? And of those cuboids, which one has the smallest surface area? That is the question we are trying to answer. So first, let's look at how many cuboids you can make. So a cuboid has 3 dimensions, right? We have length and breadth and height. Now what we are saying is, I have 12 cubes. Let's say they are of unit length. Now, how can I factorize this? You need to understand what we are doing here. When I write it as 1 into 1 into 12, that means that I am taking along the length, I will have only 1 cube. Along the breadth also, I will have only 1 cube. And along the height, I am going to have. That is, you're going to put all the 12 cubes in one single line, one behind the other. That is the meaning of this. Now, in this way, if you can understand this concept, that this is going to give you the exhaustive list of all the possible cuboids that you can make from 12 cubes. The reason being, the volume is going to remain constant, right? The volume is going to be the same because I have 12 cubes. They are not going to, the volume cannot be, a new volume cannot be created, or the volume cannot be destructed like it happened in the case of surface area. So the volume is going to remain constant, which is length into breadth into height. So as long as I make an exhaustive list of how I can write 12 as a product of 3 factors, that is going to give me all the possibilities of the cuboids that I can make. Okay, so this is one possibility. So if I retain 1 here, and I'm going to take the next 2 is the next least factor for 12, and then I'm going to have 6 here, right? I'm going to have 1 again here. Next is 3. If I have, I'm going to get 4, right? And next is 4, so it will going to be repetition. Now I'm going to extend this. I'm going to write 2 here, okay? And once I have 2 here, I have 2 and 3, correct? And after that, when I have 2 here, if I put 1 and 6, it's going to be repetition, correct? And then after this, you can see that, you can quickly check that there is no other possibility. That means that there are only 4 such cuboids you can form using these 12 cubes, right? So let's look at it. This is going to give help us in forming these cuboids as well. So the first one is 1 by 1. That means that my length is also 1, right? My breadth is also 1. Okay, this I'm going to take as breadth, and my height is 12, right? Okay, if you want to continue with that particular dimension that L and B makes the base, we can do that. Once I align them in one line, you can make it stand, right? So this is the cuboid we are talking about. Now you can change the orientation. If you are comfortable with the height as 12, you can make it stand one on top of the other, right? But this is the cuboid we are talking about. This is my first cuboid. So here, let us quickly look at the surface area because I want the smallest surface area. It's nothing but twice of LB plus BH plus LH, right? Which is nothing but 50. Correct? Square units, whatever the units are, right? 24, 25 into 2, 50. So that is my first possible cube. Now coming to the second one, you can see that one dimension is 1, right? And the second dimension is 2. That is, I have 2 along, this side. I'm going to take it as 2 along this side, right? And the third dimension, if I take this as 1 and this as 2, the third dimension is this. This is going to be 6, right? So these are my 3 dimensions. Right? So let me again explain. 1 by 2 by 6, that is, this height is 1, right? And this over here is 2 and this is 6. Now all I need to do is simply fill in the gaps. You can see now this is the second cuboid, right? So let's look at the surface area of this cuboid, right? So I have LB is 2, BH is 12 and LH is 6, right? And I have 40 here, right? 18 plus 2, 20 into 2 is 40 square units. Now coming to the third one, I have 1, I'm going to take height as 1. I have 3 here, okay? So in one direction I have 3 and in the other direction I have 4. So I'm going to take this in the other direction. So this is 1 by 3 by 4. This is 1, right? This is 3 and this is 4. Now I'm going to fill up the remaining gaps. Right? So this is your third possibility, right? And for this cuboid, the surface area is going to be 1 into 3 is 3, 3 into 4 is 12, 4 into 1 is 4, right? So this is 16 plus 3, 19, 38 square units. Okay, so this is your third possibility. Now coming to the fourth one, I have 2 by 2 by 3. Okay, so this dimension is 2, height is also 2. I have to place 1 on top, right? And then I have 3 along this. So this is 2 by 2 by 3. What I mean to say is, so I have placed 1 on top of the other here. Okay, what I'm saying is, this dimension is 2, right? This dimension here is also 2. As you can see, I have placed 1 on top of the other. And then this dimension is 3. This over here is 3, right? Now, I'm going to fill up the gaps. Right? So, this is the fourth and final possibility of a cuboid using 12 cubes. Right? Now, let's look at the surface area. What is the surface area here? I have 2 times LB4, BH6, LH is also 6, right? This is nothing but 10 plus 6 is 16 into 2 is 32 square units, right? So this is your fourth possibility, the final one, right? Let's try to look at it from all directions. This is your final possibility, and you can see that if you compare all these 4 surface areas, you will see that this is going to give you the least smallest surface area. So that is your question. So coming to the next question, they are asking us, after the surface area of a cube is painted, the cube is cut into 64 smaller cubes. In order to cut into 64 smaller cubes, you need to have, as they've already shown, four units on each side, on length, on breadth, and as well as on height. Now, how many cubes have no face painted, one face painted, two faces, and three faces painted? Let's start from three faces. Okay, if you look at three faces painted, you will see that this right here, okay, which contains the corner of the larger cube. Okay, this is three faces painted, right? So three faces painted, I am going to have, for three faces painted, I am going to have along the corner, that means I have 8 corners that we have already discussed. So I have 8 such cubes, right? Now come to two faces. You can see that these along the edges have two faces painted, right? These along the edges. Now along each edge I have two such cubes, right? And how many edges do we have? We have 12 edges. So 12 into 2 is 24. And then one face painted. You can see that these center uh, 4 cubes, if you consider if you consider one particular face, then these 4 right here in the center have only one face, whereas the rest of them have either 2 or 3, right? So 4 of each face, and you have 6 faces. 6 into 4 is 24. So one face is 24. Now, what about 0 faces? You don't have to actually calculate it, because you know the total is 64, right? If you add this up, you're going to get 48 plus 8, 56. So if I subtract 56 from 64, I'm going to have 8. That means that no face painted, you're going to have 8 cubes. That is completely in the interior of the cube. You're going to have 8 cubes, okay, which has no face painted on it. So that is the answer. Next activity that they have given is in order to derive the formula for the total surface area and the lateral surface area of a cylinder. This we have already done in the previous video, right? And then find the total surface area of the following cylinders. So you know that it is 2 pi RH. 2 into pi is 22 by 7. R is 14. 2 pi r, total surface area is r plus h, right? 2 pi r into r plus h. R is 14, h is 8. So that will make it 22, right? So if you simplify this, you're going to have 44 into 44, right? Square centimeters, which will give you, after calculation, 1936 square centimeters, right? You have to calculate this. Next I have height is 2, r is 1, because diameter is 2. So 2 into pi is 22 by 7, r, 2 pi r is 1 into r plus h, right? H is 2, r is 1, so r plus h is 3, okay, square meters, right? So this is going to give you 6 into 22, 132 by 7 square meters. So here, let me scroll it down. It's not visible. A little further, right? Yeah, now it's fine. So this is the calculation part. 2 pi r, which is 1, into r plus h, right? And you have 22 into 6, which is 132 by 7 square meters. So that is a try this question. Note that lateral surface area of a cylinder is the circumference of base into height of a cylinder. Can we write lateral surface area of a cuboid as perimeter into base into height? Yes, you can do that. So the answer here is yes. Okay. Next question. So they are talking about an aquarium, which is a cuboid. LBH are given to us. Find the area of the paper needed. Now here each question, the required area varies depending on which part you're going to cover. They're going to cover the base, the side faces, and the back face. So they're going to leave out the front face and the top. So accordingly, you need to draw the figure, right? And you're going to carefully calculate each area of each rectangle, and that will give you the required answer. The internal measures of a cuboid are given. Whitewashing. Whitewashing is done only for the walls, therefore you have to take the lateral surface area in this case. If you have 24 cylindrical pillars, the radius is given, the height is given, so you know the surface area. They're asking curved surface area, which is nothing but lateral surface area. So 2 pi r h is what you need to find out, and then you find the cost. Find the height of a cylinder whose radius is 7 and total surface area is given. If the radius is given and you know the formula for total surface area, you can find out the height of the cylinder. So with that, we finish the theory part which is concerned with exercise 9.2. In the next video, we will be looking at solving all the sums of exercise 9.2.